2.4 number 63 is one of those create a function problems that some of you guys like, but a lot of you I know completely hate. There is no one right answer to this. But if we follow their little stipulations right here, we all should come up with a graph that has a couple of important characteristics in common. So we're supposed to draw a graph of a function on the closed interval from 0 to 5 with this property here for number 63. F, the function, is not continuous at x equals 1, but here we go. The right-hand limit, x approaches 1 from the right of f of x, and the left-hand limit, x approaches 1 from the left of f of x, both of those one-sided limits exist and are equal. And actually, you know what? They could have just said, boom, boom, get rid of that and that. They could have just said the right and the left-hand limits are equal. That implies that they have to exist. Two things can't be equal if one or both of them do not exist. But anyway, they were just trying to give you a nicer shove in the right direction. So the fact that the left and right-hand limits are going to be the same right there means that this function does have a limit as x approaches 1. But if the function is not going to be continuous at 1, that tells me that we have got to be dealing with an open dot and not a closed dot here at 1. But what happens to the left and to the right of that open dot, they have to connect. So without making this real complicated, to the left of this point, this thing can do really anything we want it to do. Since this was drawn on a closed interval from 0 to 5, that should be a closed dot right there at 0. Okay, and it goes to this random open dot at x equals 1, and then from there you can make it kind of do whatever you want up until we get here to 5. But what's going on here, guys? My left-hand limit and my right-hand limit, they're both approaching the same value here. I'll just generically call that L. So the way I've drawn this right now, the right-hand limit and the left-hand limit, they both exist and they're both equal to each other. But the only other thing I need to cover, f, the function, has to be not continuous at x equals 1. And the way I've drawn this right now, let's see here, that works. Draw the graph of a function on 0, 5. I'm trying to think here. It doesn't say the function has to be continuous from 0 to 5. So I feel like what we have drawn right here is good enough. It would also be okay, though, guys, to put in a value of the function at 1 just somewhere other than L. So if I were to just put a random dot right over here somewhere, that does the same thing. So that last dot that I drew right here could be there, or it could not be there. Either one of them would satisfy the criteria they laid out for us here in number 63. Now, your graph might look very different than mine, but we need to have this in common right here, guys. An open dot at x equals 1, and then the graph connected to that open dot on either side.